I guess this is like my opportunity to interview you a little.
Oh
Like,
God. Oh no.
Yeah, how is what value are you bringing to Airbyte?
Hey everyone, welcome to the video. My name is Justin. I am a developer advocate here at Airbyte. In this video, me and a good friend, Abhi, are going over a general overview of the connectors that you can build using our CDK. We're going over file structure, individual classes and their methods, and just breaking down piece by piece what goes into building a connector using Airbyte for an API. And so we cover things like pagination, authentication, general paths, and base URLs, all those things wrapped up into one long video. I cover this on my live stream. If you are at all interested, please check me out at twitch.tv/chow_codes. The link will also be down in the description if you want to check out similar videos live. But anyways, let's get to the video.
There's potentially some really exciting stuff to be done at Airbyte. And one of the coolest things that I like about it, even though I'm not there anymore, is the fact that you get to create things that a lot of other people are using, and you get to collaborate on really important projects. And this is actually an example of that. So what I've been working on and what I wanted to work on with you, Chow, is basically a connector for the software called Orbit. And if you're not familiar with Orbit, Orbit is a community management tool that allows you to see like different interactions across your different communities, and it helps you aggregate that information and show like who's really participating in your community. And at Plural, where I'm at, we want to be able to move this Orbit data into our visualization studio. We use Apache Superset for that. The way that we do that is we use Airbyte. We can use Airbyte to pull the data from Orbit into our data warehouse, where we and so this is like a very real scenario. And once I create this connector, everyone who wants to move data from Orbit can now do that. And so there's this really cool collaborative experience that we're kind of like partaking in. So
one of the things that we need internally is getting data from Orbit into a better place so that some of our team can use that. More specifically, like our events people, marketing, things like that.
Yeah,
they're gonna need that kind of data to do some of the tasks that we need done. Yeah. So this is going to be a good connector for us for sure.
Exactly. So there's so many people in their organizations who use this. And yeah, like when I was at Airbyte, I used Orbit to look at our community. So yeah, I'm sure you're going to be using that a ton. But yeah, so basically what we've got here, I finished up pretty much all of the base parts of this connector, and we can walk through. I feel like there's a few things that we should probably walk through. One of those things that we should walk through is just kind of the project structure of like, what is a connector at its root? What are the different parts that make up a connector? Justin, so you've made a connector before. Why don't you answer me this? Like what makes up the connector, and why don't you help me walk through these files?
Yeah. So I think the main structure right now, or the main directory really, is like this source underscore Orbit, where it contains pretty much the building blocks of everything that the CDK offers, right? Or the Airbyte CDK offers. So right now you're in what? Streams.py. Well, I guess we start spec.yaml. That's like the better place to start.
Yeah, that would be the best place to start.
Yeah, so this is where we kind of like spec the overall connector itself in terms of when you're in the Airbyte UI, whether you're in cloud or open source, you need to input some data in terms of like, authentication, in terms of the actual, like in this example, you have API tokens, you have a workspace, a start date. So these are all like required fields. You have API token and workspace. So those are the two things that we have to input from your specific instance of Orbit in order to kind of authenticate and connect where your data is coming from to Airbyte, right? This is where we kind of spec that, which is why it's called like spec.yaml, and say like, hey, these are the things that you need to provide as a user to then have Airbyte send data over to our destination. And then we'll set descriptions, patterns, any other like things to make this more explicit and I guess easy to read when it comes to setting up this connector.
Yeah. So what you described was pretty much correct. We have at the beginning our inputs for our connectors. So the first thing that we define are the inputs. So when we use this connector in the UI, this is the first thing that a user is going to be interfacing with, right? This is the first thing the user is going to be interfacing with. They're going to have to provide that all of these these parameters. So this is for auth, and then we have a workspace name. Every Orbit account has workspaces under it for each of your different organizations and companies. So we need to specify this workspace as it is required with the API. Something good that we can do here is we can go back and forth between the Orbit API docs, and that's actually a pretty good way for us to basically try out. All right, cool. So if we go to the source Orbit, we go to spec.yaml. Yeah, I'll let you navigate through all of this.
So the source,
we were in spec.yaml, but now we're in source. So yeah, the first thing that we need to do in order to create a connector, and the first thing that a connector does is checks that your input is valid, right? Mm-hmm. So what we can do here is the way that we're going to check that the input is valid, we're going to attempt to fetch the workspace that we're in. And the way that we can do this, I'm going to link you the docs for Orbit and for the specific API call that we're implementing here. So if you want to pull up that, this is the endpoint that we're going to attempt to use in order to test that all of our input is working correctly. Now we have two pieces of input, right? We have two pieces of input. One is the API key and one is the workspace name. In order to test that our inputs are correct, this is the perfect endpoint for that, because it tests that we can both authorize with the API, and it tests that our workspace exists and is correct. So let's just say that you misspelled the name of your workspace, right? In Orbit, you misspelled the name of your workspace. Then this would catch that because it wouldn't return the right. It would basically fail to return, right? Let's just say that you misspelled your API key or you didn't give the correct API key. Right. Then it would throw back a fail, right? Yeah. So that's why I implemented this stream first. That's why I implemented this endpoint, because it acts as a perfect check.
Right.
Yeah, it acts as a perfect check for this. So if we go back to the code, cool. So now if we can go into workspace, the stream, there's a few things we need to do. So I have a different file called streams.py where I implement workspace. So workspace is basically a class that wraps Orbit streams. So it inherits all of the methods from the Orbit stream class. In Airbyte, we need to define every one of our endpoints as individual streams. And so all of them usually are going to inherit like a kind of a main class of streams. So, and this class does a few things. First of all, we have an init function. Init functions always run before all of the basically everything else, right? Python looks at basically the underscore init underscore and will automatically run that before anything else. What we're doing here is we're basically making sure that all of the arguments that are passed through the Orbit stream are kind of assigned into the self
like
object.
This instance of the stream, and like the only argument that we have right now is just workspace.
Yeah.
For now.
Yeah, exactly. And you can tell we're not actually passing the API key through because we're using Airbyte's native token authenticator, right?
And that's in the source.
Mm-hmm.
Okay.
So basically everything that we need to define is, do we need to add any additional request parameters to the API call, right? Mm-hmm. And the answer is we don't. We don't need to currently add any additional request parameters, because if you go back to the API docs, right? Orbit's API docs are actually really cool. They're interactive. So you can actually, if you have an Orbit API key, you can actually test out. So you actually go back to shell, because we're not actually, right now you have the language in Python, yeah. So you can actually see like what this API call would look like. And it's a really simple call. It's just calling the workspaces endpoint.
But I do like the interactiveness of the docs. It's actually pretty cool.
Yeah, it's really cool. I think they use a site called readme.com.
Is that what their docs are built on?
Yeah.
But yeah, so like I guess if you put in the header the API token right here.
Yeah.
Then it just shows you all your calls to the left, which is actually like really, really nice. You don't even need like Postman or anything to test it, which is cool.
So yeah, check it out. I just put in my workspace, and then it actually builds out this request for you on the right. Mm-hmm. So see how it added the workspace name, and then it added the JSON header and then the authorization header.
Okay, that's really sick.
And then it shows us the response. So there's a few cool things that we get from this.
Right.
In order to implement an Airbyte stream, we need to have basically build out a schema of what the response will look like for all of our endpoints. And this allows us to do that pretty easily because it tells us like, this is the latest version of the API. So this is what's returned. This is like the information that is returned. Basically here, this is the response for that API call, right? And so we now have all of the information we need in order to implement this one workspace stream. Because an Airbyte requires us to have the schema for the response, which is just a really simple JSON schema that is basically what are we expecting the endpoint to return. Airbyte can do the other side, like taking information and then normalizing it to a destination. But what Airbyte can't do is it can't just infer what it's going to get from an API.
Right.
We need to tell it what it's going to receive from the API, and this allows us to get exactly what we're going to be receiving from the API.
Right, and that's essentially what the schemas folder is, right? So I'm assuming workspace.json is going to be that spec.schema of everything that we're expecting to come back from the API. So we literally like manually have to essentially type out the whole API response and then type every single like value that's coming back.
Well, there's a bit of a cheat actually. So there's something we can do. We can use what's called a JSON schema converter.
Yeah, so I used one recently.
Yeah.
Which one did you use?
They sometimes work properly, but you have to do with a lot of editing.
Yeah. I remember one that like you'd have to add a lot of things.
You do have to add a lot of things. Like a lot of these required fields are like not accurate. Sometimes it'll also, if a field is null, it'll infer that the entire field should just always be null and the type is always null.
Well, like for some of these types, right? Like I don't like we'll just take a random one, like the ID, a type string. You could say string or null, right? Technically.
No. So ID actually can never be null.
Oh well, that was just an example, but like one that technically can be null. I know that the ID should not ever be null, but maybe something that's not in the required array here.
Exactly. Right. There's a lot of things that can be string or null. And you should have like always account for that. And it's like, and there's actually another really good example here. If you scroll up, the updated at field should be actually a datetime type, not a string type.
Oh, I see.
So JSON handles date times differently than strings. So eventually we'd want to update that to date time.
Okay.
So if we go back and we talk about this workspace stream that we're implementing, and again to recap, we are trying to use this endpoint from the Airbyte, from the Orbit API, and we're trying to pull in information about about our own workspace, right?
Yeah.
So
one thing I want to say, like this is one thing that I've done that I did when I was learning how to build connectors, and I think like for most of the stream, right? Where most of us are web dev or front end or things like that, and we worked in Express servers or some sort of backend, right? If we're dealing with full stack things. Aside from this class right here, which is essentially our parent class, everything that defines what the rest of our stream should look like. These two classes right here, so class members and then class workspace, these can be seen as API endpoints that we create in an Express server. I think that's the best way to like think about it. Hopefully that makes sense. But essentially these, like you said, are pointing to a specific API like endpoint from Orbit. This one is primarily targeting this workspace API. Yeah,
exactly. So
I'm just trying to make it like easier for like chat to understand too if they're getting lost.
Yeah, exactly. That's a good point. I sometimes take for granted that a lot of
like
the stuff that
my stream right now is like a mixed bag, right? Some of us will have some data engineers, some are front end or full stack or back end. So I just want to make sure that people are on the same page. So the workspaces class right now is literally just like this. Everything that's highlighted right now is what we're targeting. If we look back at this code right here, so this parent class that I called it has a URL base of that full base URL that Orbit has. And so every stream that is now the type of Orbit stream then takes in that base URL, and then we'll take whatever path we need to set this specific stream or class to be set to that endpoint we want to target.
Yeah, so what we're doing first is we're doing the workspace one because it's a little more, it's a little simpler, like the response that we get from it is simpler. And like I mentioned, it's the perfect endpoint for testing whether our connection is working or not. Like again, to recap, we asked the user for 2 required inputs. One required input is the API token that you receive from Orbit to authenticate that you are actually allowed to make API calls for a specific workspace.
Right.
So every API token will be be associated with both a user and a workspace. So in order to access that workspace, we need an associated API token. And so we give the API token in, and then we also give our unique workspace name. So workspace names are unique across all of Orbit, so that we are fetching that unique name that is associated with the workspace that we've created. And so this validates that both of them are correct. So in the Airbyte UI, what this would look like is that you enter both of these items, and then you click check connection at the bottom of the page. It'll start checking, and it'll make this specific function call in the backend, and running, like basically attempting to fetch the information about the workspace. And then we basically have this next function. If this works, like if the workspace stream .read records, which will basically directly call this workspace stream. If this works properly, then we just return true none, because we know that we haven't hit an error. The try except pattern in Python will automatically if we hit an error, it'll automatically use the exception case, right? So once we hit an error, we will return false, and then E is the specific error that we're returning, right? So we can always just return true or none afterward, because that means that we have successfully read the record.
So I can actually show this here. What we're doing, just to visualize this a little bit. So this check connection function that we're creating here, this is obviously to authenticate to the correct instance of your using your API token and your workspace. And so we're passing this in, and the way it gets passed in is through the UI, right? So if I wanted to create a new source, which is what this would be, right? Orbit is going to be a source that you can use on Airbyte to then pull data in. So let's just, let's just use figure, for example. So these fields right here is how we're taking in the data, right? So in this case, name and count are going to be very different. Name for us in the Orbit connector would be API token, and then count here would then just be workspace. And so you would input, your API token, whatever that would be, and then your workspace name, let's just call it Airbyte if it wants to type. Oh, it only takes the numbers. But anyways, you get the point. So you can actually, this is how you input it. And then when you set up source, that's going to run this function, take in the data that you've inputted here as your API token and as your workspace. And then like Abhi said, I know one of you guys asked who's speaking, Abhi, who is my former coworker, where he currently works at Plural right now. Then it'll run this function, try it using the data you've inputted. And then if everything checks out, if you've inputted a correct API token and a correct workspace slug, and this actually exists on Orbit's end, then this will return true. And then we can say, okay, cool. So the user has inputted the correct information that we need to kind of connect with Orbit. Shut up.
Yeah.
And then you move on to the next step. But I just wanted to show a visual of hey, this is how this looks. This is what we're trying to do. And then this brings us back to this section, the spec.yaml, which is where we've said, okay, this API token field or property should be of type string. The title is going to be API token, which sets this field right here. Is it required? Yes, API token is required. So that's why we'll have the asterisk, and you cannot continue without filling out this field. Same goes for the workspace. So this is also of type string. We have Abhi's put a description here of what that is, as well as the API token, and you cannot continue until you've inputted both of these fields. And there's another one that's start date. So if you wanted to put in a date to start where the data starts getting replicated, then you could put that, but it is not a required field, which is set right here. So I just wanted to put a visualization to it so everyone is following. Hopefully that makes it a little bit more clear.
Yeah. I'm glad that you had an actual Airbyte instance running.
Yeah.
I didn't know if you did. Otherwise, that makes it a lot easier.
Yeah, exactly.
It makes it a lot easier to follow along. I actually want to point out something really cool before we move on. This is for people learning Python. This will be an interesting lesson, and it's something that I don't really code in Python that often. So this is something so I'm constantly learning new things. So the next function only works on, so you see that built-in next right there, right?
Yeah.
You see next parentheses workspace stream, which is the workspace stream that we instantiated right before that.
Right.
And then we use the method read records on it, and then we pass in a sync mode. So the reason that we use next is because workspace. So the read records method on our workspace stream returns what's called an iterable. So an iterable is really nice because it allows us to basically return the members one at a time. So we can iterate over it in a for loop. But it does, and we're not using a for loop here, but that's the reason, that's kind of like this weird reason why we're using this next call, because we are just asking it to return the next thing in this iterable.
Right. One question that we have right now. How I make sense of this is that Airbyte is mostly generic/opaque pipeline, is a mostly generic opaque/opaque pipeline that allows you to give them a fitting in the form of functions to fill in the parts that aren't generic, like how to get data from Orbit. So Dorella, to answer your question, that as far as I know, right, or from what we do here, like all of this is generated. So this whole file structure here, if I go back one, so all of this is generated by the CDK, the connector development kit. And so what we're trying to do with the CDK is we're trying to make it easier for anybody, really, any dev out there, a data engineer, to create a connector by providing a standard, which, like you said, functions. So if we go back here, so there's these standard functions that we have where you can actually fill in essentially some of the key aspects of whatever API you're trying to create a connector for. So in this case, right, we have the Orbit API that we're trying to hit. And so if I go back go back here, go back to streams, right? So we have everything that we need to fill in. So we need to fill in a URL base. We need to fill in what parameters are being passed in. The next things are then like request parameters, next page tokens for pagination, parsing through the response. So all of these are like built in by the CDK, and we're just trying to make it easier for you. Like this is a just standard of building connectors. It should not be hard like it is without using a platform like Airbyte to create. And then, then you have a standard of how to create API calls essentially through Airbyte. So that way we can kind of either use them for connection checking or actually to get data from. So that's kind of what this is. And Abhi, if you want to fill in or like kind of go on that, you can too.
The answer to Dorilla's question is yes.
Oh, okay. Well, I just went a little too far in. Well, I also wanted to explain for other people, right? Just in case.
No, I'm glad that you explained it.
If I gave it to you first, it just would have been yes.
No, yeah, I'm glad. That's why I let you take that. But yeah, the answer to Dorilla's question is yes. Like Airbyte has a bunch of generic structure around creating the pipeline. There's a bunch of this code is just automatically generated and written for you. I wouldn't call it opaque. I think that's the one thing I wouldn't call it, is that because everything is like very visible about what's going on. You can dive into like, it's opaque insofar as if you don't look at it, it's opaque. So I guess it could be like, it's like translucent, right? So if you don't want to dive into it, because it's completely open source, if you don't want to dive into it, then yeah, it's essentially opaque. And then you fill out exactly what you said. You fill out what isn't generic. So like, what information are we retrieving from Orbit? What information do we need to get data out of Orbit? And those two things are unique. So I think you exactly nailed it. And then Deep Chill AOE 4 says like, what is a connector? And a connector is just anything that allows you to move. It is an attachment to either a data source or data destination that allows you to move data in or out of that source or destination.
Right.
So, yeah.
Yeah.
So for example,
can I give a visual?
You can go ahead and give a visual.
Yeah. So here's like Deep Chill. This is essentially what a connector looks like, right? So there's two steps. There's a source, there's destination. Those two things combined create a connector, right? Imagine like you're plugging a USB into a PC. Like let's say you have a mouse, right? You have a USB, you plug it into a PC. Your source is the mouse, the destination is the PC, right? In order to create that connection, it needs to be plugged in somehow. And so that Airbyte is effectively doing that part, where we have a source and you have plenty of different sources you could choose from. An easy example, some of our GA ones, let's just choose Salesforce, right? Salesforce, you have a bunch of data in there that you want to move, right? So take the analogy of your mouse. Coincidentally, you want to move that data somewhere, right? You want to move your mouse or your cursor with something. And so we have to create that connector, send the data from Salesforce over to a destination. And with destinations, you have places like BigQuery, data warehouse, S3, Redshift, Databricks, all, you name it, right? Any Postgres, MySQL, for those of us who are more familiar with databases, as opposed to like any of the cloud offerings. You can even turn them into JSON or CSVs here, but those two things together create a connection or a connector. Hopefully that makes sense and this visual helps, but That's essentially what we're trying to do here.
Here's the thing, right? We're as we've mentioned, we've talked a lot about like basically the implementation details of like how are we checking the connection, how are we defining the inputs. We should, I think, do an overview, like a complete overview of just kind of going through how we check each of these individual things. If you could pull it down and run run the actual like Python commands, I think that would be awesome.
Yeah. Well, I haven't actually should I fork yours? No, I should probably just clone it, right?
All you need to do is just clone it. Yeah.
Okay.
So you don't need to fork mine.
All right, bet.
So just go to,
I'm just gonna do this. I'm just gonna create a directory.
Just make one. Yeah, make one called me. Yeah.
You'll forever be on my work laptop.
Nice.
All right, let's clone this thing.
And Airbyte's a really big mono repo, which means that every part of Airbyte is located inside a single repository. There's some advantages to it, but it makes it really, really giant.
Yeah, which is okay. I got it. Yeah, I didn't do that. It's okay. We'll make it work.
Yeah, we'll make it work. Right?
I'm pretty sure I should be in it now, right?
Yeah, you're in there now, so you can run. You should be able to run the checkout.
Can I be in the top level? Oh, I see what you're saying. There you go.
Okay, so you're on. So
Yeah.
I think you're on that branch.
Yeah.
All right. So we're good. Okay, so we have the source orb. Okay, cool. Yeah, we're all set. What is
Say something else. Say something else. You wanna talk mess about my font? Huh? Join the rest of them. Everyone in chat talks mess about my font.
I haven't seen this before.
Okay. All right. Yeah.
As we described before, we're now looking at the orbit stream, which is the generic version of all of the endpoints that we're going to implement from orbit. So orbit has a lot of different endpoints, which means there's a lot of different information that we can fetch from orbit. We can fetch information about specific community members. We can fetch information about activities that community members are doing. And each of these endpoints delivers objects. If we look at the members endpoint, we're going to be fetching member objects that are it's stored in a certain schema, or the Orbit API exposes this JSON data for us, which allows us to list all of this JSON data and allows it to fetch it as long as we give it the right API keys. So now that we're fetching down, let's just say members, we're going to implement a stream that's specific to the members endpoint. So we have this first generic stream. So we have this generic stream, and then we have all of these methods that we define, and then we're going to have the member stream that's going to wrap around this orbit stream class, and the member stream is going to inherit all of these methods back from that orbit stream. So we can see in the function signature we have class members orbit stream. So it's basically going to inherit everything that orbit stream was. It's going to be an orbit stream plus something a little special, right? Mm-hmm. And remember, like Dorilla was saying earlier, it's like, hey, like we're going to be looking at like adding basically the parts that aren't generic, right? And this is another part that isn't generic. This is something that's special to the members endpoint. And what's special to the members endpoint is that specific path that we're using. So if we go up to the URL base, so if we go back to the URL base at the top in orbit stream, so that is the base URL that all of our endpoints that are going to be from, right? Mm-hmm. So all we need to do is add on what that endpoint name is going to be, and that's exactly what our path function is. Our path function just says what are we adding on, and so that's what we're doing right here. We're taking that workspace value that we've passed in from the config. Remember, we asked this from the user early on. We've passed this workspace value down through to our members stream, and we're going to use that, and we're going to do a bit of fun Python string formatting. So in Python, in order to format a string to get a variable name or a variable value into a string, we use this little F before the double quotes, which basically says we're going to do some string formatting, and then we use the curly braces and the variable name inside those curly braces, and then we get the Dorilla says the actual name of this thing, which is good. String interpolation.
And I guess for those JavaScript folks, it's like template literals. That's essentially what this is. So instead of an F and then like quotes, I believe there's quotes, but like in JavaScript it would be $sign and then the curly brackets and then whatever inside. So the self.workspace, like I said, is going to be whatever is put into the field when you actually create the source.
So here's all the endpoints to the left. Like, so if we go on the Orbit API,
yeah.
So here's all the different information we want to be able to pull from Orbit. And so the members, so we have the members overview here, and this is going to include all of the information that will help us define our schema. The main thing that we want to do is we want to list all of our members in the workspace. So if we go to list members in a workspace, that's going to be the main operation we want to do from this endpoint, because Airbyte we want to be able to fetch this information in a digestible format. So we don't want to necessarily get a single member, because that doesn't really make sense. If we implemented getting a single member, then a user would have to set up a different Airbyte connection for every single member they're going to retrieve. Right. So, and we're not going to use list members in an organization, because that, I think, will not be useful for a generic use case. So when we implement this stream, we're going to implement the most generic, the most usable version of this endpoint, right? And that's going to be this list operation. And then what we can do is we can go see on the right, we can see if we see in the request builder, v1/workspace slug/members. So if you remember, if we go back to our code, you notice that that's what we interpolate into the string that we built there. So that's how we found out, okay, this is how
this is how that we've got to use. And we already have, like Abhi said, we already have the base URL that the members stream already wraps around. So we have this already. This is provided to us. And then self.workspace is, like I said, the workspace slug that we inputted. And this is assuming that we've already checked the connection and it's a valid API token and workspace. Then we can use this members stream to then call the workspace/members endpoint and get that data coming from there.
Yeah, exactly. And we do the same thing for Workspace, but Workspace works slightly differently. It's interesting because if we go to the workspace endpoint, if we look in,
docs.
It's actually reverse. We do workspaces / and then so that's why this path function needs to be implemented differently for every single endpoint, because not only are there going to be different, there's obviously every endpoint is named something different, but every endpoint's going to have different naming, like, and different different parameter conventions.
Yeah, but I think that's the beauty of all this, right? Is that you can create these streams and then customize it to whatever the way, the endpoint is structured, right? Like exactly like you said, these are flipped, but we have the flexibility to actually do that.
So Dorella actually asks a very relevant question. So Dorella asks, like, how do we tell Airbyte what custom parameters your connector needs? So now this is a great question. Yeah. If we go back to the Orbit API, let's go to the members API and we can show a real instance. So it's going to be in that request param function, but if we can show a real instance of this, right? So if we go to list members in a workspace, because that's the operation that we're going to be implementing.
Params.
Exactly. So let's go ahead and enter a query param. Let's do maybe start date. I think start date could be cool.
Yeah.
If we go, just enter a start date like here. Do like May 1st, 2022, like 05-001. Yep. I don't know if that's the correct format, but it doesn't matter because it's just
so now go a check. So I think we're good.
Oh, we're good. Cool. So now go to the request builder. On the right. So basically this is a query parameter that we could implement optionally into any of our endpoints.
Yeah.
So there's two. Yeah, go ahead.
I was going to say that is going to be done in this request params function that's like assigned to us, right? I did this in my connector, but so this is already generated for us on the base Orbit stream, and in here is where we would say, like, those would be the request parameters that are tied. But so the question is, I guess, would we assign this in the members specific stream and not in the overall like Orbit stream class itself?
So that's actually a really awesome point. You could do either one.
Okay.
So start date is actually not a valid parameter that you can pass to workspace. Right. But there might be a case in which you need a request parameter on, like, there's some APIs where every single call needs to be associated with a specific parameter. And if we do have a very generic case, then we can go ahead and put that in the generic request params, right? But instead, what we can do is if we create the same request params function in the members stream that inherits Orbit stream, it will override this request params.
Exactly. So yeah. So like with this, like we said, we would essentially just take this request params function here, paste it down into the members. That's where we can then go in here and say, okay, these are all the query params that we have. Which ones do we want? Well, we want start date. So then we would add start date as our members specific query parameter. And then this will be then literally our CDK will, I guess, inject this the same way after the URL. So that way we have this query parameter. It's all dynamically done for us is what I'm trying to say. We don't have to manually input a query param. This is handled for us.
How does Airbyte know to ask for it in the UI though? That is something that we would need to define in our spec.
Right. So yeah, let me show it. In the spec, so this is something that it'll ask for. And in the spec, Abhi's actually already done that. In the properties field of the spec.yaml, there will be a field not required, but there will be a field present when you go into the Airbyte UI that has start date. And that's where you'll list the start date. And then so for every single query parameter that you would potentially need, optionally or required, you can then add those in the properties. And then whoever the user may be, you'll go to, let's just go to this again, right? Let's search for a connector. Let's say Salesforce. These are the required fields, but if there was start date, which Salesforce does have, it contains our title, the description, and then whatever start date in the format that we need it. And then that would effectively be added as a query parameter to whatever endpoint needs it.
And you can actually see right here that this start date isn't required either. So you see all those stars next to all of those inputs, and start date is just kind of like an optional one. And if you don't put a start date in and you don't have that query param attached, it just fetches all data.
Exactly. So this is exactly, I mean, it's literally one-to-one with how we have it set, except for, obviously the description might be different, but again, that's how we would handle that. So the more query parameters that we would need. So if we go back to this, if we needed more than just start date, let's say we also need location, we need identity and weight and so on and so forth. We know how to essentially go for it, right? And so we would just add those into, sorry, I keep switching to the wrong screen. We'd add that into the properties. We'd give it the type that it would need. For example, let's just say location, we know it's of type string. We give it a description. So for whoever is coming to input the data, you'll have this description here describing, okay, this is what this is, right? So for client secret, this is client secret of your Salesforce developer application. Okay, that's what I'm looking for. And then in the field, we could have, this format here or this pattern be displayed as well. So that way you kind of know how to input it. And this has been done here in the pattern.
Exactly. Yeah. And I think the really cool thing about this is that we can really customize all of these inputs for our specific connector. There's actually a really unique case that is not going to be, that will never occur with any other connector. If we go to the Orbit API, I can show this.
Yeah, I'm there.
So what we can see is orbit level, right? And just as another recap of what Orbit does, Orbit aggregates, you basically integrate it with all of your community tools, whether that's Discord, Twitter, GitHub. You interact it with integrate it with every single place that your community members are basically doing activities. And Orbit will look at all of this and rank how many of your community members are like which community members are like doing the most activities, what kind of activities are they doing, and depending on the kind of activities they're doing, Orbit will assign an orbit level to each of these people. So like orbit level 1 is going to be the people that are closest to you, the people that are building, the people that are like really championing your project. And then 2 is going to be maybe they interact a lot, but they don't actively build, and so on and so forth. So we can actually build in an orbit level as an input to this connector. So let's just say you wanted to set up a connector to only pull in orbit level 1 and 2 members, right? We can set that up as like a query parameter that we tell Airbyte to add on if specified in our Airbyte inputs, right? And so that's like a really cool unique case of like this specific connector.
Right. And I think like another use case for that too, right? Like, so if you're trying to separate orbit levels, you can essentially create multiple different connectors with that specific parameter being different. And that way you can kind of separate, right? So if I have one connector with orbit level 1, I can create one with orbit level 2 and so on and so forth.
Yeah, I mean, I think that may very well be a reasonable use case, but I think people would maybe be able to kind of figure that out at the destination, because this is information that you can like separate at the destination, you didn't even want the data for like orbit 3 and 4 like members, right? So then you can like filter this, and the really important part of this, and the really important part of why you like have a start date parameter, is because it's really, really expensive and it takes a long time to pull in like tons and tons of data. So let's just say you have some historical data that you really don't want to pull in and you don't want to include because it's going to be a really expensive ETL, like a really expensive data movement operation. And so you want to sometimes scope the amount of data movement you're doing down, because it's obviously going to be really expensive. It's going to take a lot of time.
Right.
And if you're running these on a frequency, so Airbyte allows you to sync at a certain frequency. It allows you to resync every X amount of time, usually every day, but you can do it up to every 30 minutes.
Yeah, I can show that right now. So Gorilla asked the question, is there anything stopping you from writing an expensive transform in a stream if you really wanted to? Do you know about the runtime environment that is running the function you wrote?
So there is nothing stopping you from writing a really expensive transform in a stream. The thing that's stopping you is probably our code reviewers when you try to submit it upstream. There is the runtime environment that is running the function that it's pretty much just everything is baked down to a command line executable that runs on a Docker container. So anything that would hold up that single threaded operation in that command line executable would basically affect performance, right? So if you somehow baked in a really like, if in Python, in the Python code, you baked in a really expensive transform, you could hold up the data movement operation. But obviously it's sort of difficult to do that unless you did it really intentionally. So you'd have to kind of go out of your way to do that. We do a lot of the Airbyte, I think a lot of the ways, the paradigm that we generate the code in, basically enables you to write code that just moves as much data as humanly possible over, and it kind of makes you think about transforming the data in the destination and not necessarily in the process. So for those who are familiar, there's this concept called ETL, and there's another concept called ELT. Justin, do you want to explain the concepts and kind of like the differences between those for the other viewers?
The first one that came first was ETL. Essentially, E in both of those stand for extract, T stands for transform, L stands for load. And if you think about it, ETL and ELT, essentially chronological order of when those processes would take place. And so both of those you do extract, right? So you extract data first. That's the first step. The differing aspects of both of those are going to be the T and the L. And so for the top part, ETL, you transform the data before you load it. And then on the ELT side, you extract, load, and then transform when the data has reached its destination. And so we're starting to see, in my opinion, that's what I'm starting to see is more ELT, which is what Airbyte is on. We extract and then load. After the load is complete, then we transform the data, which then it's less expensive in terms of like all the processes that we'd have to do, right? It allows for more flexibility, things like that. So those are the two differences, really.
Yeah. And Durla kind of followed it up saying, yeah, like what if you could skip the step for further down the pipe? And that's just kind of going back into that ETL paradigm, right? So you could set up a stream to use the ETL paradigm, but the problem with that is that relies on like a data engineer constantly managing those transforms in the stream, right? If you're submitting a connector back up to open source, we want that connector to be as generic as possible. We don't want to bake transforms into it because for every single person using that connector, those transforms may not apply, right? So you could fork the connector down. You can take a version of that connector, bake in your transform, and save those costs. That's the cool part about it, right? If you wanted to bake in those transforms, yeah, you could totally fork the connector and bake your own in, right? Airbyte also directly integrates with DBT. So we have a direct DBT integration in terms of you can just have like a DBT repository, and we just directly connect to that. And so, and we pull it in, and we actually use DBT for our automatic normalization. So I don't know if those costs would be saved considering that we actually directly integrate DBT into our platform. But also I say we as if I'm still...
Yeah, it happens. It happens.
But yeah.
I think the main point there is how expensive it is to transform before loading that data in. and being a little bit more flexible in terms of like potential schema changes and things like that. You know, pipeline breaking due to a schema change, right? Like that would be kind of cumbersome to fix and to maintain all the time. And so to do the transforming after the fact, I think would be much better. And I think more flexible in terms of like catering to certain business needs that any of the analysts, scientists need, and lets you kind of model different tables or things like that to whatever the business needs are.
Honestly, Dorilla is asking all the right questions though. Like that's like, this is the, like you could do that. Like you could pull down like an Airbyte connector and just totally like customize it, and you could totally just skip using DBT by just baking in your own transfers. Honestly, these are all like really, really solid questions that are super on point.
The underlying like beauty in all this is that that's the beauty of open source, right? You have this framework that we're giving in the CDK and all the connectors that anyone can really come and build, and you can do what you want. Obviously, like Abhi said, mentioned before, it kind of depends on what the code reviewers are going to see and like what the size of that looks like and things like that. But the possibilities are essentially endless in terms of what you can do with a connector. Obviously, there are some like certain limitations more specific to APIs, right, where there may be rate limiting and things like that. But you know, if you wanted to skip that step, like Abhi said, like it's totally up to you. It is something you can do if you wanted to skip the transform. And to note, you can send raw data. Like that is, you don't see it here for this one since we're using like test data, but the more generic connections, you can actually, you know, skip the transformation step and just send raw data to your data warehouse or database and then do your transformations there if you wanted to. But like that kind of defeats the purpose of what we're talking about here. But as an added, you know, note, you can skip transformation entirely in Airbyte and normalization if you wanted to do that on your own.
Yeah, that's also a really good point. I think the baked in normalization is a really cool part of Airbyte, and right. I mean, but like you said, you don't have to use it. Do you want to like wrap up by like just covering just the last parts of this connector that I built out? I think I want to kind of talk about the two things that are left to do on this connector. Okay. Right.
And I'm guessing it's what is commented out.
Yeah. So there's this thing that's commented out, and that's this orbit stream paginated. So if we just remove the comment, just take out those backticks.
Hey man, I know Python, I got it.
I'm just narrating what's going on.
Well, you Dr. Seuss.
Yeah. So what this is, and this is another really cool aspect of the CDK, is that everything is kind of built off of this one orbit stream class. We can build off of it, we can customize it, we can use it for different functions. Let's just say that you have an endpoint that needs to be paginated. There's different endpoints you can get from an API. Some endpoints will return very little information and will basically return one object. For example, let's just say we have an endpoint. If we go over actually back to the Orbit API, sorry to make you jump all the time, but I'd love to give the viewers some context. This is going to retrieve one specific object and one member. This is not a API call that needs to be paginated, right? So if someone was creating a Airbyte stream for getting one specific member, pagination will not be required at all, unless for some unholy reason that it's like the object is so big. But you would never do that. You would never paginate like we're creating just retrieving one object, right? But there are going to be some streams that will retrieve lots and lots of information, and you will want to use whatever whatever the API's pagination scheme is to basically batch the data that's coming in, and the way that we do that, we can do that through implementing this function called next page token. Next page token is a function that will handle it'll handle the case for there being another page from the API response. A lot of APIs will return data automatically paginated, and in order to retrieve the next page or the next set of data, that you will need to access the URL to that next set of data. And this is what we're doing exactly here. We are passing in the response data. The response data contains in it an object called links, and links will contain an object called next which holds the URL to the page, to the next page of the API response, right? Is that, I feel like I said a lot of things there.
No, it makes sense.
Does it make sense?
Yes,
right?
It does make sense.
Yeah. So basically, this is how we access. So we have one page, which is going to be in its own URL as a certain part of the response. And then we have another part of the response, which is going to be stored in another URL because it's not going to be able to return the entire response in one package. So we have it split up along a certain amount of pages. So we say that like and this code doesn't work yet. So this is what I've been working on.
Right.
We say that if this next URL doesn't exist, then we can just return and say, hey, we're done. There's no more pages. We don't need to look at it. That is the else part of the statement.
Right.
But the if says, hey, if it's not none, then let's return this URL so that we can now use it in our path.
Right.
And so we can now like access the next page. And this allows us Airbyte to work with any different style of pagination, because this is not the only style of pagination. This just happens to be the pagination style that Orbit uses. Some other APIs use what's called a cursor-based pagination strategy. Mm-hmm. And so that's why we have this next page token function heavily customizable, so that for whatever API you're using, you can adapt your Airbyte connector to that API's pagination strategy.
Now, I would say I prefer this method over the cursor based. This is just a lot easier to work with, and at least on the code side of things. So this is good. So now I guess my question for you when building this, so like we have this next page token function.
Yeah.
Is the request params how you're actually like fetching from that URL, or how are you going about that?
The way that we access the next page of results is by appending this URL information about like the next page in the response to the request, right? So you can see that we do pass these params in where it says if next page token, meaning that like, so it'll basically run this function if next page token returns a URL. So if it returns a URL, it'll update it with the new URL. And then we'll go on to the next page, right? And then it'll keep doing that until if next page token is false. Right. Mm-hmm. And once that's false, we then return params.
Gotcha. Okay.
And I don't know if all of this completely works yet. So we need to, the way that we just need to kind of like work on debugging this, and maybe we can do that another time because we've been talking about this for a while.
Yeah.
But the other interesting part of this is that we're actually building this stream on top of our base Orbit stream, right?
Right.
So what this allows us to do is it allows us to only use this paginated stream type for the streams that require it. So if we want to turn like the members, the workspace like stream shouldn't be paginated,
right? Because
that's just one object,
right?
So we don't want to use the paginated stream for that. But what you could do is you could go over to, if you head over to like the members stream, you can turn the member stream into a paginated stream simply by changing the type there, right? And by changing it to Orbit stream paginated.
Oh, I see. And then now it's kind of like this like tree of things. So yes. Orbit stream paginated would then be wrapping around Orbit stream, members wrapped around Orbit stream paginated, but still inherits all the methods that are inside of the Orbit stream class, the parent class.
That's correct. Yeah. That's correct. Yeah. So you get to build out the structure of like, hey, like if you want, let's just say, if you want pagination, you can add it to that specific stream, and all of these functions. So like this next page token function will overwrite the regular Orbit stream next page token. So if you go up to, well, I know we talked about this earlier, but
it overwrites this main one that really doesn't return anything.
Exactly, right. So because the main one just assumes that the response isn't paginated, right? So
and then that would probably be the same for the request params.
Yes, exactly. It's the same for all of these methods.
Copy that. Okay.
Including the init function.
Gotcha. Obviously, so on and so forth, right? So parse response is probably going to get overwritten and things like that. So this makes sense. So the to-do list on this connector right now is to make this Orbit stream paginated work. Once it works, then we can wrap members around it and then test.
Exactly, right. And the step after that is adding incremental sync.
Right. But we're not even thinking about that right now. We still got to work on this first.
Yeah, exactly, right.
Okay.